and how to find the roots of a quadratic function by factoring. We are going to be doing 3 items today, so copy them down, and here we go. So the first thing to understand is what is the zero product property. If we have two real numbers a and b and we multiply them and the result is 0, that means either a is going to be 0 or b is going to be 0, or actually they could both be equal to 0. So the same way, if we multiply two factors, x plus 3 and x plus 2, and the result is 0, that means one of these factors must have been 0. So keep in mind that this can even apply to 3 factors. So if you have a times b times c is equal to 0, any or all of them could be equal to 0. And then you could extend this to even more factors. Let's say we have 4 items that are being multiplied and the result is 0. Any of these could be equal to 0. So knowing this property, we are going to solve some quadratic equations, and these are the steps. Copy them down and I will explain to you. You may want to pause the video while you're copying this down. Remember to follow each one of these steps carefully when you're solving quadratic equations, otherwise you will end up with the wrong answer. And all answers must be written in a solution set. So here we go. Factor completely to find the solutions. I want you to show all the work exactly as I am showing it to you right now. So here we have a trinomial and we have made it equal to 0. So the first step is to make it equal to 0, make sure it's in standard form, and then you factor it. Because it's a trinomial, you are going to look for factors of 1 times 15, which is 15, and these are our choices. Obviously the 3 and the 5 work better. If you know how to factor this the quick way, you may, but I'm going to show the long way. The answer is still going to be the same. So this one was fairly simple. It's just x plus 3 times x plus 5 is equal to 0. And since two things are being multiplied and the result is 0, either x plus 3 must equal to 0 or x plus 5 must equal to 0. So you now have two equations and you're going to solve each one of them. Turns out that x is either negative 3 or negative 5, and you're going to write your answer as negative 5 comma negative 3. And what you have really done is found the two roots or the two x-intercepts. And the x-intercepts are where x is equal to negative 5 and x is equal to negative 3. Let's try another one. So this is obviously not in standard form, neither is it equal to 0. So you're going to move the terms around so you have the standard form equal to 0. We're going to multiply 4 times 18, which is 72, and then look for factors of 72, which will give us 21. You're going to split the middle term into minus 24 and plus 3x, and then use grouping to do the factoring. Turns out either x minus 6 is going to be 0 or 4x minus plus 3 is equal to 0. Solve these two equations and x is equal to either 6 or negative 3/4, which you write in a solution set. Again, you have found the x-intercepts of the function. Here's another one. Remember that the first rule of factoring is to look for GCF. Try it before you watch my steps. Pause the video. Here goes. X is common. Inside we have a trinomial. So what factors of 24 are going to give you negative 10? Turns out to be negative 6 and negative 4. And now we have 3 factors equal to 0. That means any one of them could be 0. You solve the two equations on the right and you get 2 more x values. This equation has 3 roots. And this has 3 roots because if you look at the exponent, it's a 3. It's a cubic function. So it intersects the x-axis 3 times. Let's try another one. Again, see if there is a GCF. If not, follow the rules of factoring. This has 4 terms, so you must factor by grouping. And once you have done the factoring, you want to check to make sure that each factor cannot be factored any further. This second one here is a difference of squares, so you must factor it further. And now you're going to get 3 factors, the product of which is equal to 0. So any of these factors or all of them are equal to 0. You solve each equation, you end up with 3x values, and those are your solutions. Now all of these lead to word problems. So this word problem is in your textbook. Make sure you read it first before you start doing the work with me. In this problem there is a frame, and the inside of the frame is 11 by 17, and then it says that you want the frame to be the same width all the way around the total, and the total area of the frame is 315 inches square. So if you want to increase each dimension by x, the outer dimensions are 2x plus 11 and 2x plus 17. So the total area is the area of the big rectangle, which is 2x plus 11 times 2x plus 17, and that has to equal to 11. And that actually has to equal to 315. And that is wrong. So we're going to just change that. It should be 315. And then make the equation equal to 0. Simplify, factor out the 4, and what factors of 32 will give you 14, and that is 16 and 2. It turns out that the only number that works here is x is equal to 2, because you get 4 we know is not equal to 0, and x plus 16 would give us a negative 16. That cannot work. So x is equal to 2. Therefore the dimensions are increased by 2 on each side, all 4 sides. So the dimensions are 15 by 21 inches. And that is it for today. Goodbye.